Welcome back, fellow coders. My name is Fernando. This is the Fern, and in today's video, I'm going to go over a university assignment that TheCherno made on his YouTube channel. Well, he actually reviewed the original assignment and then he did it himself. So I will put links to both of those videos in the description, and let me just show you what the assignment looks like. We can pause the video. Okay, so that is the top part of the assignment. And this is the bottom part of the assignment. Now, I'm not going to go over like the entire assignment because I think he explains it pretty well. So just pause it here. If you want to recreate this assignment without looking at my code or his code, just pause it, go through the requirements, and then come back and compare the code with us. Now I'm going to be doing it in Rust. He did it in C++. But since I'm learning Rust, I'll figure why not just kind of port the code to Rust and learn a few things along the way. So once you've read the requirements, you'll have a basic understanding of what we have to do. The assignment itself is not too difficult. It's just like a really bad, but it's really not put together like very well. It's just a university assignment where you have to do a bunch of random things in order to get a grade, which is not very realistic. Like I've never done any of these things on my back-end job. But anyways, the gist of the assignment at its core is this. We have a standard input, and then we're going to get the string from the start input. Then that string is going to be different tokens. Then we're going to break down those tokens into what is going to be an add or a delete command. And then it's going to be a little more processing after that. But we'll get into that later. So this is the gist of the assignment. It's pretty simple because it is. First thing that we need to do is we need to create a new cargo project. So make sure that you have installed Rust, and that should install cargo. Yeah, we'll just call it uni assignment 1. You can call it whatever you want. It really doesn't matter. And then once that is, then we're going to open that in Visual Studio. Let me copy our basic test. Later on, I'm going to copy and paste some unit tests that I created. Oh, also, I forgot to mention on the TheCherno video, the one that I showed earlier, if you go kind of like at the end of the video, he has around 10 cases. I went ahead and copied like the 5 shortest ones. He didn't post that code anywhere for us to like easily copy and paste. So it is kind of hard to like go through all. There are some long ones and the letters are kind of random. But I think if you go through my 5 unit tests, it should be fine. So the first thing that we have to do is we need to declare a mutable input string, and actually I'm not sure if this needs to be mutable. Oh yes, it does need to be mutable because we're going to assign a value later on. So that's a mutable input, and then we're going to read a line from standard in, and let me check my notes. Yeah, standard library should be automatically imported. Well, we don't have to import that. So it should be standard IO, standard in. We're going to use the read line. And then we're going to give it the mutable reference for the input. Now, here we'll give it an error. If for whatever reason we can't read the input, there. Now the next thing is that we need to split our standard, our string input into different tokens. And we're going to split it by white space. Split white space. That's going to give us pretty much this into individual tokens. So this will be token 0, token 1, and so on. And we can actually, in fact, just print everything so we know we're on the right track. So for a token, not sure how big this is going to look. Okay. So do a cargo run. And let's just do random strings here. It doesn't matter. As long as there's a space in between. And then we'll get them printed out. Which is what we want. The assignment really doesn't say what to do if the string is too long. Like, it tells you that the key needs to be 10 characters. Here, we could exit the program earlier, but I'm not sure that's the right thing to do because we can still process other tokens. But we can still give a warning here. And if I'm doing anything crazy in Rust, just let me know if you're a Rust developer. I am just beginning to learn Rust within the last couple of weeks. I come home and I do a little bit of rustling here and there, and I do a little bit of code wars in Rust. Okay, so we have a token and the token length. And here we're going to say key. And now you're wondering why we're saying 11. So if it's greater than 11, then that means it's 12, or larger than 12. And the key needs to be 10, but remember that the first character is a sort of a command character, so that one doesn't really count towards the length. So here, actually before here, you could validate to make sure that all these tokens are correct. So I'll leave that for homework for you. In my case, I'm just going to print out this error, or not really an error, just a console output. Let me get rid of this. So now the next thing to do is we have to break this down into two parts, one being the key and the other one being the command. And you see right here, so we have this. We need to get these and then Apple separated. So let's create a new variable. We'll call it entry key because that's what it is. And it's going to be a token. And this has to be a reference. So what we're saying here is that we want to get from here all the way to the end. We don't want character 0. Now we need to get the 0 and compare it with a string literal. In our case, A and B. We can just copy this. B. D for deletion. And just to make sure that we are on the right track, we can just go ahead and print this out. Entry key. And we'll go ahead and do the same for delete. And we'll need to do A and whatever. Now note, if we do something else, we should just ignore that. There you go. And did I type the same thing for everything? Pretty close. but so that's working. And so here we actually don't need this. But what we need is a hash table of some sorts for the assignment. It's really not a hash table, but that's what the assignment is calling it. So we're going to need an F method. And here we are going to give it the entry key. And we're going to do the same thing for, but this is going to be delete. Now, of course, we haven't defined hash table yet, but we will in a minute. So for our definition of hash table, there's a few things we have to do, but let's just go ahead and declare it here. Now, this is how I kind of work with it. When I'm saying create a new hash table, initialize it with 26 values. I'm not sure if this is like the best way to do it in Rust, but that's how I ended up doing it, and it worked. All right, so let's declare so the hash table is going to have items. Remember, we need the key and the slot, and they're both strings. So let's go ahead and create a public struct. Which is going to be item. And each item is going to have two things, a key and a slot, and they both are strings. Now we want to define a default for item. So in Rust, we need to call implement default. And then we call the function default. And this is going to return an item where the key is empty. And the slot is set to never use. So this is kind of going to initialize our item to these default values. We also need a public struct called hashtable, because that's where we have to store our items. So we're just going to call it list, and it's going to be a vector of items. So far, so good. Now we have to implement hash table. If you come from other languages like C++ or Python or just about any other language, really, when you create a class, everything kind of stays together, like the members, the functions. Well, in C++ it'll be the header file and then the implementation file. But still, it's kind of roughly together into two files. and you declare in one, you implement it another. Here is almost kind of the same thing. You would declare the struct. The struct kind of holds your data and it's always private. And then once you have your data, then you can implement functions for that data with the keyword implementation. So we'll implement the very first one that we need, which is the new. That's going to take size because remember, we only want 26. Here you can say self or just say hashtable. Either way will work. So here we need a mutable list. We will then call another function within our implementation. And then lastly, we need to return our new hash table. Now let's create init. So we have a mutable list of items, and then we also need the size. Then we'll just need to initialize for and here's where the default will come in handy. So let's see. Let's comment this out. And then let's make sure that we have 26. And let's use this formatter here. I think I can copy it, yeah. Just this one. I don't believe I can't use that. Let's just let's just go ahead and create a new function here called public. And now when we're doing internal functions, you need to declare self. Whether it's mutable or not, in this case, we don't need mutable, so it's going to be self. For now, we don't need anything in return. And now let's just do let's actually do enumerate, and then we can do something like this. So we'll put the index there. And then the values. And I believe that should work. Let's try it out. Yeah. And you see how we initialize everything to never use, which is what we want. Okay, now let's work into the add function. But before we do that, we actually have to implement a few things. Let's do get index first. And this is going to return U32. Now, so here's where we have to get the last character. According to the requirements, we'll get the last character, and that's going to be our index for the slot. So if like the last letter is, for example, B, that will be A will be 0, B will be 1, C will be 3, D will be 4, and so on and so on. So we have to calculate that number based on the letter. Now, lucky for us, the letters have an ASCII value. So we just have to subtract the A, and then that's going to give us like the proper number. So let me just write it, and then we'll get the last value, we'll unwrap, and then we'll cast it as 32 minus and that's going to give us our value. So if the string is the last value is going to be E, and then if we actually count A, B, C, D, E, that should give us the fifth index will be the 4. So just let me show you the ASCII table here so you get an idea. So if this value is E, it'll be 101 and then minus 97. And that will give us 4. And then so 4 will be the slot that we want to look for in our hash table. We'll just put here A is 90. Yeah, A is 97. We'll just put this kind of comment here for us if we ever forget what we're doing in the code. So anytime you have any sort of, and I wouldn't say this is complex, but anytime you have something that you think someone else might read your code and might not understand what's happening, you can have a little comment there, say, hey, I'm doing this, and expect this result, and so on. Okay, so now we have our index. Now we can implement the git insert index. Because remember, we need to find an empty slot. If that slot's not empty, we have to go to the next and to the next until we find one empty. All right, so we'll need our get index as a start. Then we want to loop until we find the correct insert, the correct insert index. So if it's never used, then we found our spot. Or if it's tombstone tombstone. So we can break and we can return. In Rust, you can break and return in the same line. And also inside the loop, if we haven't found, like, if the slot is used, then we need to increment by 1. And that's going to be about 26. We only want to increment by 1, and then once you get to 20 to 25, now once you get to 26, then it goes back to 0. Actually, I'm not sure if it should be 26 or 25. It might be 26. But anyways, another thing here is that the requirements really doesn't say what to do if everything is full. But you should always have an exit strategy on your loop. Like, you don't want to loop here forever. If all of our slots were full, this loop will run forever. So, you know, I can put here as kind of homework for you guys. Something like that. We want to write safe code, right? We don't want to run code that can potentially break. And finally, before we can insert, we have to compare if that key is the same as the slot. Otherwise, we should not insert it. And then we also need an out. Which is going to be a mutable reference. Oh, and we actually need to return Boolean here. Actually, here I don't think we need reference. We already get in the reference from here. So this should be the same here. Now, if we find the key, then we need to dereference this here to get the correct value from the reference. Then we found the index where it's already there. So same as before, we are breaking, exiting out of the loop, and we return true. Let me copy this. However, if it's not found, we're going to return false. And actually, yeah, this. Yeah, it is possible that we could kind of merge these two with some code application there. But anyway, I think these functions are completed. And we should now be able to work on our add function. Now this will be a mutable self. Here we need a mutable index. And now, even though we might not use it here, we could give none or sort of an option to the function, but I'm going to leave that as a kind of homework for you and for myself, because I haven't really learned kind of implement option arguments in Rust. Then we are going to see if it exists. And here we need and mutable index. Like I said, we don't need it for add, but we're going to need it for delete. If it exists, then we should return. We don't care about anything else. But if it doesn't exist, we need to find the insert index. And that's going to be our insertion index for the key in slot. And let me just copy this. Now here, normally we should be using enums. But because the requirements are so strict, we can't use enums. But in a real world application, you want to use enums because if you mistype like occupy with 1C or 2Ps or whatever the case might be, this is just going to render our comparison on the find function useless. Okay, so now that we have add, we are good to go to add stuff. So let's look at an example here. Let's go ahead and run this, and let's just add. Let's say Apple Now here we should see only one apple inserted because the key is already there. And as we've expected, apple once. The second apple is found, so it's not inserted. But orange is because it's not anywhere else. Okay, so we're almost done. Now we have to implement the delete function. And let's just do it right up down here. Just copy everything here. Now here, this is going to be inverted. And let's delete this. And this is going to go to tombstone. And I believe that's it. Let's run this example. Make sure that this works. And we have strawberry and orange. Apple get deleted as tombstone is like deleted. And so the last thing that we have to do is we need to kind of format our results a little bit better. And so here we're just going to use a mutable keys vector. And then we're just going to join at the end. So we can save item. And again, this is where you will use an enum. Yeah, Russ is going to complain that we're not using this. We can just do underscore for now in case we need it later. And the last thing to do is return this as a string. Yeah, so if we run this, yeah, I'm not printing the result. try that one more time. And there you go, orange and strawberry. And that's what we would expect. Now, before we move on to the unit test, let's just go ahead and kind of recap what we're doing and some of the things that we can make better. So we have two variables here that are immutable, our input string and our hash table that we actually implemented ourselves. Then we read the input, we split it by white space, and every single token is then treated as individual token. We compare the first character to A or D because we can only add and delete. And then we take the rest of the string as an entry key because that's going to be a fruit or whatever. Lastly, here on our main, we print the result just for us to see it. Now, I'm not sure where should I'll just put here in main. So some of the things to improve on. For the slots, we could use enums. We could implement a full table function. And this is going to help us out break out of things so we don't have to run while loops, etc. And I'm not sure if this is possible. It's got to be possible for our optional arguments. But I'm pretty new to Rust, so if this is not possible, let me know in the comments. Or if it is possible, just link to some type of documentation where I can follow up on. And I think that's it. The class itself is pretty easy to implement. And lastly, what I want to show you is let's do some tests. And let me copy that one. I don't want to retype the whole thing. And then we just have to import that from the top. Oh. And so if I run cargo, is it test? We should see 5 results. 5 OK unit tests. And this is a unit test. And then we have a fixture. The fixture is kind of working as our input validation. Yeah, if you want to copy the long test from the TheCherno video, it's gonna have to be like a manual thing. I'll put my GitHub repository for this project in the description, and feel free to submit PRs if you'd like to. So I think that's gonna be it for this video. Pretty new to Rust. Let me know what you think. I'm thinking about making more videos, like make small projects in one language, which is easy, maybe like Python, then port them over to Rust or C++ just to see the contrast of languages and learn a little bit more about each language as we go along. Let me know what you think about that idea, and thank you for watching.